Hidden inside every language model that has ever impressed you, underneath the transformers, the attention layers, the billions of parameters, there is a map, a multi-dimensional map of meaning, and nobody built it. Every word in the English language has been given a precise location in this space. Words that mean similar things live near each other, not because anyone placed them there, but because a machine read a vast amount of stuff humans ever wrote, and the structure emerged on its own. But if you remove this map, every language model ever built stops working. GPT, Gemini, Claude, Grok. This is the foundation everything runs on, and almost nobody gives it enough credit. To understand why this map matters, you need to understand the problem it solves. Computers work with numbers, only ever numbers, so before a machine can process language, it has to answer one question. What number do you assign to a word? Let's start off with our first instinct. Just give every word a unique number, an ID. Dog is 1, cat is 2, table is 3. And this seems perfectly reasonable, right up until you try to use it. Because look at what the numbers actually say. Dog and cat are distance 1 apart. That seems right, they're both animals, but cat and table are also 1 distance apart, which means the computer thinks cat is just as related to table as it is to dog. And kitten could get assigned an ID number, let's say 7823, magnitudes away from the word cat. Okay, that didn't work. Let's try another attempt. Instead of one number, give each word a list of thousands of numbers, all zeros except for one position, which is a 1. This technique is called one-hot encoding. Now, every word has a unique fingerprint, but this creates an entirely different problem, and it's a fatal one. In this system, the distance between dog and cat is exactly the same distance between dog and table, because every pair of words has exactly 1 0 swap for a 1 between them. The math comes out equal every time. The geometry is a perfect equilateral triangle of meaninglessness. Think about the word cold for a moment. Right now, without any effort, your brain places it near words like winter and ice, maybe even lonely, depending on how you've lived with that word. That's the thing a one-hot vector cannot do. It can represent words, sure, but it cannot know that any word is near any other word. Both approaches collapse for the same reason. They treat words as labels, not as locations. What the map you saw at the beginning of the video does is completely different. It gives every word a precise location in a high-dimensional space, not a label, not an ID, but a place, and the distance between two places encodes the relationship between two words. Here is how the geometry of meaning actually works. Start with something simple, temperature. You plant 5 words in a 2D plane and watch what happens. The model places them along a line, a temperature axis, without anyone instructing it to. The geometry chose this arrangement purely from the statistical patterns in language. Hot and freezing appear in completely different contexts across billions of sentences, so they end up far apart. Warm and cool share many contexts, so they end up closer together. And lukewarm, a word that was never explicitly placed, where does that go? Now we can scale this up across every domain of language. Animals cluster near animals, countries cluster near countries, emotions pull towards each other. The entire space organizes into a geography or meaning, and every cluster exists because the words inside it share similar context in real human writing. But 2 dimensions can only encode 2 kinds of relationships simultaneously. Real embedding spaces use multiple dimensions. Each dimension is another axis of meaning the model discovered. One could be for temperature, one for emotional valence, one for geographic scale, and others no human ever named. And in this, something remarkable happens. The model was never told that Paris is the capital of France. It has no encyclopedia, no geography textbook, no explicit rule, and yet if you draw an arrow from Paris to France and then draw an arrow from Rome to Italy, those 2 arrows are basically identical. Almost the same direction, almost the same length, every single time. The same arrows 6 times in 6 different places in the space, because the relationship between a capital and a country is a geometric property that the model discovered entirely from patterns in text. And here's the part that should genuinely unsettle you. If you rotate the entire embedding space, spin the whole map, every relationship is preserved. The arrows stay parallel to each other, the clusters stay intact, the distances hold, but the directions have completely changed, which means the actual directions don't even matter. Now here's where this gets truly strange. Take two completely separate language models, one trained exclusively on English text, one trained exclusively on French text. They have never shared a single parameter, a single data point, a single training step, and yet when you look at the geometry of their embedding spaces side by side, something unexpected appears. Take the word dog in the English space. Its nearest geometric neighbors are the words that surround it most closely, such as puppy, wolf, bark, tail, pet, etc. Now go to the French space and find the same concept. Its nearest neighbors are these words. Yes, I'm not gonna butcher the French language here, but the point is, the neighborhood structure is strikingly similar. Both models independently learn that whatever dog means, it lives near whatever wolf means, because in English text and in French text, those words appear in similar contexts. This pattern repeats across every concept in both languages, which suggests something significant. The geometry isn't a feature of English or French. It may be a feature of the concept themselves. Language is just the surface. Underneath, the relationship between ideas might have a shape that any sufficiently trained model in any language tends to rediscover. Now, at this point, the natural question is, who even built this map? The intuitive answer is a team of experts, linguists, scientists, engineers who sat down and carefully placed every word by hand, encoding every relationship deliberately. But that answer is completely wrong. Nobody ever placed these words. The model learned every position by doing one thing, predicting the next word in a sentence, billions of times. That is the entire training objective, not to understand meaning, not to even learn relationships, just given everything you've read so far, what word comes next? Get it right and the positions of coffee and hot nudge slightly closer together in the embedding space. Get it wrong and they nudge apart. Every individual nudge is invisible, a fraction of movement, but repeat 400 billion times across a huge amount of text. These nudges accumulate into the map. Watch what the space looks like in different stages of training. Early on, it's pure noise. No structure, no cluster. The model knows nothing. By the midpoint, regions begin to coalesce, vague shapes emerging from the chaos, and by the end, the geometry is crisp. Every cluster is sharp. Every relationship is precise. I want to reiterate this point though. The model was never told what animal means, never given a rule saying countries belong together, never shown that emotions form a neighborhood. Every category you saw in this map appeared spontaneously because words that mean similar things tend to appear near similar other words. Every benchmark you've ever seen for a language model, every leaderboard score, every capability claim is entirely downstream of this step going right. Every word you know, you learned from context, not from a dictionary. Nobody handed you a definition of warm when you were 2 years old. You inferred it from 100,000 moments, sunlight, a blanket, a voice, a cup of something, until the word found its place in your internal map. The mechanism is identical, just the substrate is different, which means your map is shaped by your life. Grow up in a cold climate and winter sits near home and familiar. If you grew up in a warm one, winter might sit closer to absence and strange. Same word, but different address. Overall, we built a machine to predict the next word, but we didn't expect it to discover the shape of thought.